Welcome to the SmartSkeMa video. We prepared a series of videos on the SmartSkeMa system, and this is the first video where we introduce the SmartSkeMa system and give an overview of its functionality.
SmartSkeMa is a community mapping system. It can process information from sketch maps to merge this information with other land tenure information from maps or from other data sources such as UAV images. SmartSkeMa was developed as part of the It's for Land project. It's for Land is a European Commission Horizon 2020 project funded under its Industrial Leadership Program.
This video will give you some background information on the SmartSkeMa system, including the relevance of sketch maps and the different components of the SmartSkeMa system and how they work together, and we'll show the workflow. There is a second video which you can have a look at where we introduce use cases and also give you a live demonstration of our web interface.
SmartSkeMa is a community mapping system using sketch maps as input. It supports a bottom-up approach to land tenure, land rights, and land resource mapping that uses freehand maps. Usually, aerial images or traditional surveying techniques are used to collect information about the topography of spatial features. Our tool enables people who are involved in community mapping to use sketch maps in addition to traditional methods to enhance the information from aerial images or from surveyors with information from locals, for example, information on the rights or the constraints on spatial features. The main objective of Work Package 3 is to implement a sketch-based geospatial data recording tool, which is called the SmartSkeMa tool, the Smart Sketch Maps tool. Why sketch maps? And what is a sketch map? A sketch map can either be a freehand map drawn on a blank piece of paper, such as the example that you see on the left. This is a sketch map that was drawn by one of our participants in the Maasai area in Kenya. A sketch map can also be a map that is drawn on top of another georeferenced map or an aerial image. We see an example of this kind of sketch map on the right side, which is a sketch map that was drawn on top of an aerial image of the area Robert Bata in Ethiopia. Why sketch maps? While aerial images provide us with good spatial information, there is information, land tenure information, that is not visible on aerial images and that cannot be detected remotely. For example, non-spatial information such as usage rights, restrictions, responsibilities, and the unofficial agreements on land use among locals can only be detected with the help of locals. Temporary spatial events such as those related to wildlife, for example elephant tracks, or cultural events such as the Orpul traditional camping event in the Maasai culture, cannot be seen on aerial images. And sometimes there are even spatial features that are not visible on aerial images. For example, beacons are oftentimes too small to be detected. Sometimes there are non-physical boundaries. For example, in one of our studies, we captured the boundaries of a ranch area that was confined by a river in the south and by hills in the north. But on the aerial images, it was not possible to see this non-physical boundary, the connection between the hills in the north and the river in the south. Sometimes there are also spatial features which are hidden, for example, boreholes hidden below trees. This is information that you can find in SketchMap. SketchMaps are also very flexible in terms of the size of the area that should be sketched, especially when people sketch large areas, such as the pastoralists in Kenya. Data collection via GPS is not feasible as you have to travel to the different locations in person. Satellite images can cover large areas, but then their resolution is too small to show any details. This is one of the advantages of sketch maps. People can sketch those areas where you have a lot of information and a lot of details that should be captured. They can sketch these areas larger, and those areas where there is not a lot of information that should be captured smaller. Sketch maps is also a very easy to use tool that do not require any technical or cartographic expertise. People can simply visualize their knowledge. The minimum requirement for using sketch maps as a data collection method is simply a pen and a piece of paper. And if applicable, you can use also additional information such as aerial images. On this slide, we visualize how the SmartSkeMa system is integrated in the whole It's for Land project. SmartSkeMa relies on input data from three sources. As base data, we use cartographic information from base maps. This data might be enhanced by data from UAV images that are processed in work package 4 and 5 of the It's for Land project. You can see this on the left side of the image. Here we have the authorities or NGOs which are responsible for conducting UAV flights, and they are collecting data with UAVs. On the other hand, we also have existing data sources, base maps that can be used. So what happens in work package 4 and 5 is that this UAV data is processed, features are extracted, and it can be merged together with existing base maps. And this is one of the data sources that is used by the SmartSkeMa system. The second and the major source of input for SmartSkeMa are the sketch maps produced by local communities. The spatial information in sketch maps is further processed in the object detection and the qualitative representations in this line here, while the non-spatial information in sketch maps is processed in this line with the help of a local domain model. The local domain model specifies concepts and relationships in a common ontological perspective so that different sketches can be compared and automatically interpreted by the system with a uniform conceptual language. A local domain model needs to be developed for every study area, and in this project we developed or suggested a generic domain model which covers typical concepts in rural land administration for African countries. And for developing such a local domain model for your study area, you can use the generic domain model as a starting point and extend this with the local concepts. To integrate the non-spatial information from sketch maps into official databases, we developed an adapter model that bridges between our local domain models and the standard LADM, the Land Administration Domain Model. So let's come back to the spatial information in sketch maps. The first step to process sketch maps is to detect the boundaries of objects in sketch maps and to interpret the symbols that people have drawn. Depending on the sketch map, we have different recognition rates. So there are sketch maps that are very nicely drawn and the symbols are very systematically used. And in these cases, we have extremely good recognition rates of nearly 100%. Of course, there are also other sketch maps which are not drawn as clearly and the symbols were not used as systematically because they are freehand sketch maps and people can simply draw everything they want to. In these cases, the recognition rate drops. In our field studies in Kenya, we had sketch maps where we had recognition rates also with 50 or 60%. I have to say that 50 or 60% recognition rate for freehand drawn images is already a very good result. And it essentially means that the person who is collecting and who is digitizing the land information from locals, his work is reduced by 50 to 60%, which is done automatically by the system. So having extracted all the boundaries and the objects in the sketch map, now we have to describe the location spatially. Given that sketch maps are drawn based on observations and memories, but not based on measurements, we can interpret the geolocations only qualitatively. So this means if somebody has drawn a sketch map, and in this sketch map a river crosses a marshland, or a homestead is on the right or the left side of a river, this is information that you can extract from a sketch map because it's usually correct. But you cannot extract the exact geolocations of an object in a sketch map. Now we have a list of spatial features that exist in the sketch map, and we also know which spatial relations hold between these sketched objects. As a next step, we want to align the spatial information in the sketch maps with the spatial information in the base maps. To compare these two maps, we have to bring them on the same qualitative level. This means if we compare, for example, a boma, and this boma is on the left side of a river and on the right side of a street within a marshland, we are searching for spatial features which are bomas and have the same spatial relation in the base map. So we are searching only for bomas in the base map which are on the left side of the river, on the right side of the street, and within the marshland. And we are doing this for all spatial features in the sketch map simultaneously to select candidates that align to our sketched spatial features and have a consistent set of spatial relations. This way we can integrate the spatial but also the non-spatial information that was captured in the sketch map with a traditional base map.
The core components of the SmartSkeMa system are highlighted in this blue area. Now please have a look at our next video where we introduce the use cases for the SmartSkeMa system and show a live demo of our web interface.